It has been a very successful day. I got everything running nicely for presentation. Microampere meter shows current, charging one. We also get small pulse discharge of supercapacitor, full scale 1 milliamp. There is a shunt resistor soldered to it, and circuit is just hanging around. LED pulsing is better seen in the darkness. Wiring to the coil is hidden in grooves beneath. My adjustment and fixing with Tesa. Would be interesting to set up a timer to measure period, how it changes from direction. Working beautifully, it's hypnotizing. The magnets, they tend to align south-north direction, like a compass needle. Explanation of the circuit: we have solar panel 3 volts, then diode which drops voltage half volt, and on supercapacitor we have 2.5 volts maximum voltage, and then Schottky diode drop is 0.2 volts, as small as possible. Then we have a coil, and when magnet approaches coil, it induces voltage which opens this transistor, and this transistor opens this transistor, and then current passes through the coil which also closes this transistor, and need to optimize the value of resistor to get it working. And the red flashes for short time, and recharges back supercapacitor, so the circuit is super efficient. Need large coil so that magnets and coil generate voltage larger than 0.6 volts to open the transistor. And then we have PNP transistor and NPN transistor, which are maybe not critical, but in the original drawing emitter and collector was messed up, and then it did not work. Here is oscillogram, how it looks. Here we have driving pulse through the coil, and here is back EMF, which makes LED shine. When the circuit is not working, then we have symmetrical electromagnetic induction, and if we move quickly, we have larger induced voltage. If we move slowly, then voltage is small. And for the circuit to operate, the voltage needs to exceed 0.6 volts to open the transistor. Circuit implementation, I use 2 volts from power supply, and this large coil and large magnets to get enough voltage. These coils from microwave oven, 21 volt motor, were not enough. Need 220 volt transformer coil without the core, and the circuit is not self-starting. Need to start it. To see LED flashing, need darkness. Very efficient circuit. I cannot measure the drawn current. It's less than milliamp. Lubricated bearings with WD-40, and it started to move more freely, less friction, and it's less than 0.2 milliamps. Without supercapacitor with just 1000 microfarads, current is practically zero, very slight. I think that is because of the bias resistor, that it opens the transistor a little bit. And with pendulum swinging, we have about 150 microamps average current. We can get about 100 microamps from room light illumination, and that's barely enough to sustain oscillation. shut down, get interesting transient spike, which contains 3 pulses or 4 pulses sometimes. Now I will run circuit from solar panel. It kickstarts. And here is oscilloscope. This was start kicking, and then it swings. From YouTube learned an elegant way to mount magnets, and also the thread. It's wound around the screw, and length can be easily adjusted. If there is not enough light, it cannot kick too far. But now I increase the light, hitting the solar cell, and it kicks off. Here is my understanding of the circuit. This capacitor, it's acting like constant voltage reference because it gets charged, and then it provides bias current for this transistor to open it slightly.